Hey everyone, welcome back to the channel. I hope you are doing great. In today's video, we are going to build a first-person controller in Unity from scratch. By the end of this video, our player will be able to move, jump, and look around using the mouse. So let's get started. I am starting with a new 3D scene. First, we need a ground for our player. For that, I will go to the hierarchy, right-click on it, select 3D object, and create a plane. Now let's create our player. For that, I will go to the hierarchy again, right click on it, select 3D object and create a cube. I will rename this cube to player. I am using a cube because I want to keep this tutorial simple. Right now, our goal is to understand how a first person controller works. Once you understand the logic, you can replace this cube with any character model you like. Next, since we are building a first person game, the camera should move along with our player. For that, I will drag the main camera and make it child of our player object. After that, I will move the camera a little upward and place it near the top of the cube because this is where our player will see the game from. Now, before writing any code, our player needs a character controller component. For that, we will select our player object, click on add component, search for character controller and add it. The character controller is the component we will use to move our player. Unlike a rigid body, it does not rely on physics to move the player. Instead, it gives us direct and precise control, which is why it's commonly used in first person and third person games. Now that our setup is ready, let's create our movement script. For that, I will go to the assets folder, right click, select create, C# script and name it PlayerMovement. Now I will drag the script onto our player object. Let's open the script and start writing our code. The first thing we need is a variable to control the player's movement speed. So I am going to write this line. Serialize field private float speed is equal to 5f. This variable controls how fast our player moves. I am using serialize field because I want this variable to appear in the inspector. If I feel the player is moving too fast or too slow, I can simply change the value without editing the script. Next, our player should also be able to jump and fall. For that, we need two more variables, one for gravity and one for jump force. So I am going to write these two lines. Serialize field private float gravity equal to 10f. Serialize field private float jump force equal to 4f. The gravity variable will continuously pull our player downward. The jump force variable controls how high the player jumps. Now all our movement is going to happen through the character controller. So first we need access to it. For that, let's create a character controller variable, private character controller. We also create one more variable to store our player's vertical velocity. Simply this variable stores our player's vertical movement. Whenever the player jumps or gravity pulls the player down, this value gets updated. So I will write this line, private float y velocity. At the moment, the controller variable is empty because we haven't assigned anything to it yet. So when the game starts, we need to get the character controller attached to our player. For that, inside the start function, I am going to write this, controller equal to get component character controller. What this line does is it looks for the character controller attached to the same game object and stores it inside the controller variable. Now our script can access the character controller whenever we need it. Next, we need to read the player's input. Since the player can press a key at any time, we need to check the input every frame. For that, we will use the update function. Inside the update function, the first thing we need is the horizontal and vertical input values. So I am going to write these two lines. Float horizontal equal to input.getAxis horizontal, float vertical equal to input.getAxis vertical. The horizontal axis is controlled by the A and D keys. The vertical axis is controlled by the W and S keys. These values change depending on the keys the player presses. Now that we have the input values, we need to convert them into a movement direction. Since this is a first person controller, we don't want the player to move based on wall's direction. We want the player to move based on the direction it's facing. For that, I am going to create a movement vector like this. Vector 3 movement equal to transform.right into horizontal plus transform.forward into vertical dot normalized. Here transform.right represents the player's right direction. We will multiply it with the horizontal input so the player can move left and right. Similarly, transform.forward represents the direction the player is facing. We will multiply it with the vertical input so the player can move forward and backward. By combining these two directions, we get our final movement direction. You will also notice dot normalized at the end. Without normalization, moving diagonally would make the player move faster than moving in a single direction. Normalization makes sure the player always moves at the same speed, no matter which direction they are moving. Now that we have the movement direction, we need to control how fast the player moves. For that, I am going to write this line, movement into equal to speed. This multiplies the movement direction by our speed value. As a result, increasing the speed value makes the player move faster, while decreasing it makes the player move slower. Next, let's add gravity. For that, we first need to check whether the player is standing on the ground. The character controller already gives us that information using is grounded. So I am going to write this condition. If controller is grounded and y velocity is less than 0, y velocity is equal to minus 2f. If the player is standing on the ground and already falling, we will reset the vertical velocity to a small negative value. This helps keep the player properly grounded. Next, let's make the player jump. For that, we will check if the player presses the space key while standing on the ground. If input.getKey on keycode.space and controller is grounded, y velocity is equal to jump force. When this condition becomes true, we assign the jump force to the vertical velocity. As a result, the player moves upward. Now we need gravity to pull the player back down. So I am going to write this line. Y velocity plus equal to gravity into time.delta time. This updates the vertical velocity every frame, making the player fall naturally. Now we need to add this vertical movement to our movement vector. For that I will write this line. Movement.y equal to y velocity. At this point our movement vector contains forward movement, sideways movement, jumping and gravity. The final step is to move our player. For that I am going to write this line. Controller.move movement into time.delta time. The movement vector tells us the direction. The speed variable controls how fast the player moves. The y value handles jumping and gravity, and time.delta time makes the movement frame rate independent. Finally, the move function moves the character controller using all those values. Now let's save the script and go back to the Unity. When we press the play button, we can move the player using the W, A, S and D keys, and we can also jump using the space key. Our player movement is now complete. The only thing missing is the camera movement. So in the next step, we will create a camera movement script and complete our first person controller. Now let's make our player look around using the mouse. For that we will create another C# script. I will go to the assets folder, right click, select create C# script and name it camera movement. Now I will drag this script onto the main camera because this script is responsible for controlling the camera. Let's open the script and start writing our code. The first thing we need is reference to our player. So I am going to write this line. Serialize field private transform player. The reason we need this variable is because when we move the mouse left and right, we don't want only the camera to rotate. We want our entire player to rotate. That's why we need a reference to the player object. Next, let's create a variable to control the camera rotation speed. Now I am writing this line. Serialize field private float mouse sensitivity equal to 100f. This variable controls how fast the camera rotates. Increasing the value makes the camera rotate faster, while decreasing it makes the camera rotate slower. Next, we need one more variable. So I am writing this line. Private float x rotation is equal to 0f. This variable stores our camera's vertical rotation. Whenever we move the mouse up or down, this value gets updated. Now before we start moving the camera, let's lock the mouse cursor. For that, inside the start function, I am going to write this. Cursor.lockState equal to cursor_lock_mode.locked. This first line locks the mouse cursor to the center of the screen. This will gives us the behavior you will find in the most first person games. Now let's move to the update function. The first thing we need is the mouse input. So I am writing these two lines. Float mouse x is equal to input.getAxis mouse x into mouse sensitivity into time.delta time. Float mouse y equal to input.getAxis mouse y into mouse sensitivity into time.delta time. The mouse x input tells us how much the mouse moved left and right. The mouse y input tells us how much the mouse moved up and down. We are also multiplying both values by mouse sensitivity to control the camera speed. Finally, we are multiplying them by time.delta time. So the camera rotates smoothly on every computer. Now let's make the camera look up and down. For that I am going to write this line. X rotation minus equal to mouse y. We are using mouse y because it controls the vertical movement of the mouse. You will notice we are subtracting the value instead of adding it. This makes the camera move in the natural direction player expect. Next, we don't want the player to keep looking upward or downward forever. So let's limit the camera rotation. For that I am writing this line. X rotation is equal to mathf.clamp x rotation minus 80f. This limits the camera rotation between these two values. As a result, the player can look up and down naturally without flipping the camera. Now we have the rotation value. The next step is applying that rotation to the camera. So I am writing this line. Transform.local rotation is equal to quaternion.euler x rotation, 0, 0. Here we are rotating only the x-axis because looking up and down happens on the x-axis. The y and z value stays at 0. Finally, we need to rotate the player left and right. For that, I am writing this line. Player.rotate of vector3.up into mouse x. Instead of rotating the camera, we are rotating the player object. We are rotating the player object. Since our camera is a child of the player, it automatically rotates along with it. This gives us a proper first person camera. Now let's save the script and go back to the Unity. The last thing we need to do is assign the player reference. For that, we will select the main camera, find the camera movement component and drag our player object into the player field. Now let's press the play button. As you can see, we can move using the keyboard, jump using the space key and look around using the mouse. And that is our complete first person controller. I hope this tutorial helped you understand how everything works. If you found this video useful, just stay tuned to our channel and I will see you in the next video.